Yes. Good evening, everybody. Hello.
Good evening, sir.
Good evening, sir.
Good
Good
evening,
evening,
sir.
everybody. See, how many of you have a glimpse at RCDC software? कुछ देखा?
No, sir.
नहीं, बाद में पीछे रह जाओगे?
नहीं, सर आज ही इंस्टॉल किए थे।
अच्छा, अभी अभी इंस्टॉल हुआ.
हाँ, अब भी इंस्टॉल हुआ था।
ओके.
सुलेखा जी के हेल्प से हो गया था।
अच्छा. So Sulekha madam has helped you for that.
यस सर,
So thanks तो बोला
Yes,
कि
sir.
नहीं?
थैंक्स बोल दिया मैंने।
that is the bare minimum thing that you must do. Okay, then how many of you are having any other problem than installation?
Sir, actually, I am using ETAP's 2019 version. So
Okay.
when I export to Access file, it is coming ACC file. So when I try to open in this RCDC, it's not showing that.
Yes, that is the problem. I will have to find out the solution for that because
Mm.
I'm not using 2019, but a lot of people say that it doesn't support that RCDC doesn't support 2019. But let's
Ac-
see. Yeah, see what you can do. Uh, you can create that. You can use ETAB 2019. Then that $ET file you can import in another 2016 or something, and then save it there. Create the MDB file there, and then you can read it in that. Or I will have to ask our person who is looking into that installation process. Shayad he will give you the way to get out from that. But that is a problem. It's not readable. That the version 2019 there are some problems.
Yes, sir.
Yeah.
I contacted Ajay sir, and Ajay sir told use 2016 ETAP's version.
Yeah,
Then it will be okay.
that was the my solution. I was talking. I was thinking that I will talk to Ajay, and Ajay might give me a solution for that. But when he says that you have to use 2016, then that is the ultimate answer because he is the guy who knows each and everything about installation, and he is expert in the all those pirated things, how to get converted, crack file, etc.
Okay, sir. So now we are using RCDC. Which version, sir? Which version of RCDC is we using?
That
We say,
V8i, definitely.
I
Yeah.
okay.
Uh,
Okay.
let me close this so that okay, the we'll see that also, no problem. But that is V8i because it is connected to that STAD V8i.
Okay, sir. Okay.
Yeah. But I don't know whether that STAD also has updated their softwares. So if they are using that in their Connect edition, I think it is also in Connect edition. So if you can have that Connect edition, then that RCDC might work. I don't know, but I will have to find out.
Okay, sir. No issues. I will try to use in ETAP 2016, and I will see.
Yeah.
Okay.
Okay. Then we'll start today's session. So how many? Nine are there. Few people are missing today, but okay, they will follow the recorded session. So can we go ahead? Hello.
Yes, sir.
You are prepared. Everybody is prepared for that. Yes or
यस
no?
सर।
Yes, sir.
या तो पहले ही एनर्जी खत्म हो गई. Okay, let us go and see that. So for that, the first thing what I have to do. Okay. Uh, okay, we'll have the basics first. But I'm not going in details. I hope that you know every one of you know how to design the members. But just I will open this PPT. So today we are going to see how we can design the columns. Okay. Yes.
Yes, sir.
Yes, sir.
Now, now let me minimize this. Where is that? Where is that icon that I'll hide? I was not getting this icon. That was the problem. Okay. Yes. Now we'll go to. Okay, the title. What says title? Title is manual design of column having biaxial moment. But we'll go through each and every conceptual understanding of column. Okay, then what is column? Yes, if this is a vertical member, can you call it as a column? Hello.
L effective should be greater than
नहीं नहीं
3
वो
into
बाकी नहीं 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 वो बाकी तो बाद में आएगा पहले व्हाट इज कॉलम कैन यू कॉल दिस एज अ कॉलम हेलो
excuse me sir, please
यस
share the screen sir.
आई हैव
We are
नॉट
not.
शेयर ओके
No sir.
let me see that yes I have not shared it okay now I have shared the screen everybody can see that
Yes, sir.
yeah
Yes, sir.
then uh, so I was over here. Okay, so this is the manual design of column having biaxial moment, and I have opened that PPT, and this PPT will be also with you. But let us see the basics. Basics means let's say you can see this figure. Yes.
Yes, sir.
Now, if I call this is a support, and this is a support. Can you call this as a column? Yes or no?
Yes, sir.
Yes,
No,
sir.
sir.
Yes or no? ये कॉलम है या नहीं है या तो it you may call this as a column or you may call this not as a column. तो आप क्या कॉल करोगे उसको? So this is
This is a
column,
column.
this is elevation. Yes,
This is a column.
it is a column. Okay. If I draw this, so this is plan and this is section. So can you call this as a column?
No, sir.
This is a
Yeah.
beam.
Should
No.
be.
So this is column and this is
No,
not
sir.
column.
No, sir.
ऐसा ही लगता है ना आपको?
Yes, sir.
कितने लोगों को ऐसा लगता है? So this is a column and this is not a column.
Both are not column.
Both are
Not column.
not column. So can you consider both as a beam?
Yes, sir.
Okay. Now let me know on what basis you have taken a decision that this is a column and this is not a column, or someone is saying that both are not column and they are beam. On what basis you have considered this? See, have I given you any data? ओके आई विल नॉट गो मच इनटू दैट. अगर मेरे पास समय रहता था तो मैं और ज्यादा डिटेल में ज्यादा था. बट सी हियर आई एम नॉट टॉकिंग एनीथिंग अबाउट external loading. Okay, here you this is your external loading, that is in your mind. But मैंने दिया था क्या?
No, sir.
No, sir.
See, this loading you have assumed in your mind, and based on that you have taken a decision that this is a column. But मान लो I am saying that loading is like this. Then this will be beam. And here you are considering this as a beam because here you are saying that in your mind you are saying that this is your loading. And based on that you are saying that this is beam. But I am saying no, loading is not like this. The loading applied is like this. Then this will behave as a column and this will behave as a beam. So it's not, don't prejudge anything, don't assume anything. मैं हमेशा लोगों को यही बोलता हूँ कि just have a patience and ask further queries. Don't prejudge everything. नहीं नहीं, वो दिखने में कॉलम लगा इसीलिए मुझे लगा. नहीं, ask him what is the loading, what is the sizing, what is the length. You can ask. वो आपने जो चॉइस आपके पास था उसको आपने अश्यूम किया अपने अपने मन में. बराबर है ना? यस.
Yes, sir.
So do not prejudge. Now let us go to the division. See, columns, when you are saying any member, let's say this is a member, and when you say this is a column, let's say when you say this is a column, you mean to say that it is longitudinally loaded. It is loaded in the direction of its longitudinal axis, and it is not, or it is having very minor loading perpendicular in the transverse direction. So that's why it is a column. And most of the time you will see that in columns you don't find this type of loading. You will have a loading at the end, either in terms of PU and MU. So this will be MU and this will be PU. So columns are the members which are subjected to axial loading and moments at their ends, or they may not be subjected to moments. But columns are not supposed, primarily they are not carrying major transverse loads. थोड़ा बहुत हो सकता है, but they are not. Okay. And beams, when you call this as a beam, you say that it is primarily loads.
Yes, sir.
So never ever give the answer based on uh, half information or no information. So you can judge everything based on full information. That is the case. Now, when we say that columns are subjected to longitudinal loading, then you can say that what is the effect of longitudinal load? Let's say this is your member and it is subjected to tension or compression. let's say it is subjected to tension. So what is going to happen? It will elongate, right? Yes.
Yes, sir.
Yes.
And if it is subjected to compression, then it will shorten, right?
Yes, sir.
So there will be primarily change in the length of the member. Clear? Hello.
Yes, sir.
Now, one more thing is that it also depends. See the behavior of this column. Okay. I will remove this. The behavior of column. Let's say this is my column, and it is having a cross section something like this. So this is the length, and this is application of compressive load. Because of this compressive load only, forget about moment, वो बाद में देखेंगे. So because of applying axial load on this member, and this member is having very slender cross section. You can see that B and D are very small when compared to L, right? Hello.
Yes,
Yes,
sir.
sir.
Yes, sir.
So because of that, instead of getting slender, instead of getting compressed, it might bend like this, or it might bend like this. Now this bending will depend on what type of supports it is having. Yes. So this is my support. Okay. So the behavior of column is dependent on L, B, D, and support conditions. Right? Yes.
Yes, sir.
Now let us go through that, so that you will find why these things are important in design of columns, and why we are not considering these when we are going for design of beams. See, this is your column, and it is hinged hinged over here. Okay. And it is also hinged over here. Hmm, मैंने गलत निकाला. Forget about this. So these are the two hinge connections, and when you will apply a loading something like this, you will see that it will bend something like this. Yes. Hello.
Yes, sir.
Now let us go for another column. So this is the column. Everything is same. Only support I am changing. Okay. So instead of hinge condition, now the conditions have changed from hinge to fix. Then it will bend with something like this. Okay. See, everything length of the column is same, B and D of this is same, then this is same. Only the change is here it is hinge, here it is hinge, and here it is fixed. And you will see that the behavior, bending nature or deformation of the column is changed. Clear? Hello.
Yes, sir.
Yes, sir.
Now, even then, you will go for some another case. Let's say, 1 minute. So the battery is not working. Okay. So okay, now it is okay. Now, even then, this is also, except there is only one change, is that except this hinge condition or fixed condition, now it is free. And then you will see that the column, when it is subjected to load like this and like this, loading is also same, then the column is bending like this. Clear?
Yes, sir.
So, what are the parameters that are going to affect the behavior of any column? B, D, okay, L, and support conditions. Let's say support conditions. Then, of course, you can say FCK. What is FCK in case of concrete, and FY. But in case of steel, again, you can say that. So this is the material properties. These are the geometric properties, and these are the support conditions. Okay, how it is restrained. So the type of restraint, geometric properties, and material that you are going to use will be very important to define the capacity of the column. Clear? Hello.
Yes, sir.
Now, based on that, you can say that if you can find out. Say, let us say this is my column. Okay, this is another column. And this is third column. Everywhere B and D is same. Everywhere support conditions are same. And everywhere, everywhere the loading is also same. Now, which one? You can say L1, you can say L2, and you can say L3. क्या लगता है, without going for any calculation, what you can find out? Which one will fail first?
L3.
L3.
The column having largest length.
Yes, sir.
Because this column, you can say that B, if I call this as a cross section, so you will see that based on your effective length over B, or you can say L by R. Actually L by R, but in concrete, we say that either L by B or L by D. So based on that, you can say that the behavior of column gets changed, and a flexibility goes on increasing as length of the column goes on increasing, right? So based on this, you're dividing the columns in two parts. One is short column and another is long column, right? Yes or no?
Sir, yes,
See,
sir.
Yes, sir.
I am not going in any formulas. Formulas you can see in the book, but try to understand the concept behind finding out those formulas. See, we always just go ahead with the practice that L by 12, L by 12, or L by D, I think, right? L by D whether length over that is whether it is less than 12 or whether it is greater than 12, or you can say L by R, whatever it is. So based on that, you say whether the column is short or column is long. Why we are, the first thing is that why we are finding the two columns based on their L effective to least lateral dimension, only because this is a certain ratio which has been finalized by our code or any other theory. Also you can go for uh, theory of buckling or Euler buckling load. You can see that based on this, the behavior of column gets changed. So this column has for the same other parameters, this column uh, will yield earlier than this column, and that's why for designing purpose we are finding out two different types of columns, short and long, right? So that is the first bifurcation. Now, when one more thing, when you say this is your column and column is primarily subjected to longitudinal load, most of the time compressive. Yes.
Yes.
Now you know that concrete is very, very strong in compression. So this entire concrete will itself will be able to to take care of this external loading. Then why you need reinforcement in this column? Yes. कभी ऐसा
Yes,
सोचा
sir.
है क्या आपने? See
Yes, sir.
why you need reinforcement in the column? Because okay, I can understand you need reinforcement in slab, you need reinforcement in beam because they are subjected to bending moments and tension on bottom, compression on top. But here you can say that this entire element is subjected to axial compression, and you know that concrete is very, very strong in compression, resisting compression. So you don't have to worry about it. See, I can design a column which will resist this. The only thing is that I have to go for very large cross section. Yes, maybe something around 1.5 meter by 1.5 meter. Will you allow me to go for this large section? Then this section will definitely resist this PU. Yes.
Yes, sir.
Yes, sir.
Concrete can resist that. Let's see that you are having a column something like this. Column having a very large cross section, and it is having very less. Now this is your cross sectional dimension of the column, and you can say that length of the column is just 1 meter, and cross sectional dimensions of the column maybe say 750 by 750, okay, mm. And this column is subjected to a load, this pu, maybe say 100 kilonewton. So what will happen? Does this column will get cracked or it will get compressed due to this 100 kilonewton? Am I asking very, very difficult questions? Yes, anybody? आंसर गलत है कोई प्रॉब्लम नहीं. क्या लगता है? आई एम नॉट इंटरेस्टेड इन कैलकुलेशन. मुझे मुझे बस इतना लगता है कि क्या कैन आई सपोर्ट सी दिस concrete block which is only there is only concrete and concrete of grade M25 say or M35 say. So whether it is not capable to resist this 100 kilonewton, yes or no?
Yes, sir, it can
Is
resist.
capable.
Definitely.
Capable to
Compression,
resist.
Yes,
because it is
definitely.
compression, that's why.
Yeah, it is totally under compression, and length to breadth ratio is very less. So that means if I want to go for this as a 4 meter, then I will have to increase the dimensions 750 by 750 also 4 times. So is it possible?
No, son.
Yeah,
To the
that's
space
why.
constraint is not
That's why we are taking the help of
reinforcement.
reinforcement, that we say that okay, this is the size of my column, and this is the length of the column. So, and I want to resist heavy load of say 1000 kilonewton, right? So this load may be due to 3-story, 4-story, or maybe about 5-story. So this is the load that I am supposed to resist at ground level, but I don't want this column size more than say 300 by 450 or 300 by 500. In that case, this will try to bend like this, and it might create a tension on this side and compression on this side, or I don't know the support, due to support what type of, so it might bend like this also, right? So sometimes it might bend like this, sometimes it might bend like this. That means if this is my cross section, I will have to provide a reinforcement on this side, all along the periphery. Yes. Hello.
Yes, sir.
And as I have to provide a reinforcement all along the periphery, there has to be some arrangement which will give me position of the longitudinal bars in their right position. Then I might need them to have something like this, or I might need a reinforcement like this. So finally, you can say that these are your longitudinal bars. These are your transverse bars to hold the longitudinal reinforcement in proper place. Yes, and all these longitudinal bars will resist the probable cracking that could happen because of the bending behavior, and it will not allow it to bend like this, because the stresses will be carried by reinforcement, so which is over here. Clear?
Yes, sir.
Now we'll go and see. See, basically, if you are having this concrete and you are having a reinforcement all along this, and there is a reinforcement everywhere, let's say on periphery, that means total capacity. So let's say you have to resist PU. Now concrete will say that okay, I will take care of compressive strength or compressive stresses. So you can say that is PUC plus there will be due to the see this type of bending will provide couple like this, and this couple will create Mu, and it will also this couple will create the resistance to this behavior, and that is you can say PUS. So that is the total Pu, whatever may be in kilonewtons or in any other unit, will be taken care by concrete and reinforcement. Right? Hello. क्लियर हो रहा है कि नहीं?
Clear, son.
तो इतना समय क्यों लगा दे हो यार? Okay, so that means you can get one formula something like that Pu is a combination of capacity of concrete plus capacity of reinforcement. So for concrete I am saying PUC, and for steel I am saying reinforcement I am saying PUS. So this is the shear carried by concrete, and this is the shear carried by reinforcement, and together they will see that this will not get exceeded. Okay, so you can say that this is your equation, that Pu is not more than PUC plus PUS. Yes.
Yes, sir.
Now you can see that PUC, once you know FCK, that is the compressive strength of concrete, and if that FCK is multiplied by area of concrete, you will get PUC. Clear?
Yes, sir.
And how you will find a area of concrete? You can say that this is the area of concrete. Yes.
Yes, sir.
Now about this PUS, once you define the reinforcement that you are going to use, or Fy, you can say that it is nothing but Fy multiplied by area of compression steel. That will give you PUS. Together, you will get the capacity of your column with some ASC. And ASC, you know that how you are going to find out pi by 4 d square multiplied by number of bars. So ASC you can find out, Fy you know, FCK you know, AC you can assume with some trial and error, and you will check. Now if your PUC plus PUS happens to be less than this Pu, then either you will increase B or D, or you will increase ASC. That means you will increase either numbers or diameters or both. Clear?
Yes, sir.
तो इतना सिंपल थियरी है, प्रॉब्लम क्या है? Yes or no?
Yes, sir.
Now let us go and see if you are calculating PUC and you are saying that it is something FCK into B into D, right?
Yes, sir.
But this FCK, you cannot consider entire FCK, because there are n number of other factors reducing this FCK. Or if you are considering FCK equal to 20, why you are not using Newton per mm square?
So डिजाइन पर्पस से लोअर साइड पे जाना पड़ेगा फैक्टर ऑफ सेफ्टी लगा के.
Yes. So you have to go for factor of safety. Then you have to go for other considerations. Now let us see what are the considerations. So finally, you can see that we are applying 0.4 is the factor of safety. See, the first thing is that you cannot use the entire FCK. So you have to divide it by 1.5. So you will get 0.67. Okay. Now this again, this is assuming that you are having eccentricity equal to 0, but as there is no, you cannot get this 100%. So you have to go for some E minimum, right? So E minimum has to be considered over there. Then because of that, you are going for this 0.4. So finally, you might go for 0.9. So 10% reduction. So 0.9 multiplied by 0.67, etc. Finally, you come to this figure as per our code. So finally, only 0.4 FCK BD will be the load carried by your column. That for design. It may be a little bit more than whatever as calculated. So on SEPR side, we are going, right? Clear?
Yes, sir.
Yes, sir.
Similarly, calculation of PUS. Now it is very simple that you know that factor of safety that you are applying is 1.15. So it will be 0.87, 87 FY ASC. So ASC will be considered by you, and numbers and diameters will give you ASC. And this factor is finally has been finally revised. Because this is also with the because of that eccentricity, it has came to 0.70 something 75. So that you can read in books, and maybe factor somewhere here or there. Don't worry about it. But finally, you can see that the capacity of concrete is calculated with respect to size of concrete, cross-sectional size of concrete member, then the material or grade of concrete, then grade of reinforcement and number of reinforcement that you are using. Clear? Now let us go for that minimum eccentricity. See, you can see that this is your concrete member. Let's say this is your concrete member, and you are applying this load something like this, and you say that it is acting at your center of uh, what do you call this? Yes,
Centroid.
centroid. That means you are applying at centroid. So that is okay to say on paper, but what is happening in practice? See, the first thing is that a section at this, section at this, section at this, section at this, as it is a heterogeneous material, you will see that somewhere it is having voids, right? So this is your concrete, no? Now, and you are applying concrete inside. So at every section, you will not find the same quality of your concrete. So at every section, the arrangement in this section will be different. That means this centroid itself is varying. It may vary something like this. So itself it is not one point at every cross section. So because of that, some eccentricity will come in picture, right? See, sometimes it is here, sometimes it is here, sometimes it is here, sometimes it is here. That means finally you will see that this is now, even if you apply a load over here, it is registered over here, and you will get some sort of eccentricity because this is your slender column. Because it is having a cross-sectional dimension slender as compared to length, and there is reinforcement inside this, and the quality of concrete you cannot 100%, ideally you cannot achieve it. So there will be changes in the centroid, and because of that you will get some eccentricity. I will call it as eccentricity 1, right? Clear?
Yes, sir.
Now, let's say there is another case that, say, how you are applying a load on column. See, we are not applying any load on column. The load on the column is kmi. You are getting it from beam. That means you are having, let's say this is your size of column in plan, and you are having a beam. See, if you are having exactly beam at this, only then your the chance of axial load will be over here. But what will happen if you are having a beam over here, or what will happen if you are having a beam over here? So the load will be transferred over here or over here. Yes, right?
Yes, sir.
So because of that also you will have some eccentricity E2 for E1 and E2. So one is dependent on length and another is dependent on size, so B and D, right? Clear?
Clear, sir.
Because of that, code says that E minimum has to be there, and code says that it is either, in any case it should be 20 mm minimum, or L by 500
Plus
plus
lateral dimension by 30.
B or D by 30. अब ये दोनों में से जो भी बड़ा होगा, means I will say that E minimum shall not be less than 20 mm and shall not be less than whatever this calculation. Now you can see this is taken care by that E1 and this is taken care by E2. समझ में आया?
Yes, sir.
ये आपको किसी ने बताया नहीं होगा. Where from this E minimum has been calculated by code. जिन्होंने कोड बनाया उनको क्या भगवान सपने में आके उन्होंने ये फॉर्मूला दिया क्या? What is the base? So base of this formula is one is the length parameter, another is the cross sectional parameter, and based on that code is trying to say that even if there is no moment on the beam, on the column, even then you will have to design the column for this E minimum. And this E minimum is based on length of the column and cross-sectional dimension of the column. Clear?
Yes, sir.
So accordingly, this is the best thing that I can give it to you. One more thing, what I will have to go for. Okay, short column and long column. Again, because of long column, there is further reduction. Okay, one more thing that what will happen? What will happen if this is your column and this is your beam? Now this beam that you are considering as a rigid junction, that means this beam, as it is applied by lateral loads, it will create a reaction. So reaction will be here, as well as it will have a moment. So moment is this, right? Hello.
Yes, sir.
Yes, sir.
That means if I call this as a column cross section, this column, see the moment is this, so the column will have a moment like this. So this is mu and there is pu. So there is pu. Now this column has to resist pu and mu. Because of that, there are various uh, analysis process has been there. Let us say that now try to understand this, and if you don't understand, please ask me. See, this is my column, and this column is this is your cross section, and I want to see a strain diagram. So entire column is subjected to axial force only. Then what will be the strain diagram? So strain diagram will be something like this. So this will be compressive. So I will call this as a minus epsilon c, or epsilon minus epsilon. Yes, it will be under compression, no? Every
Yes, sir.
So if I am drawing this, let's say this is D and this is B. So if I am drawing the strain diagram for this entire depth, so everywhere you will see this. Now let us see, now where is the neutral axis for the column, and what is the property of neutral axis? See, when you are having a bending like this, you say that the neutral axis will be something like this, and a location of neutral axis will be such that the strain diagram will be linear. ऐसा ही बोलते हैं ना? So we say that this is the depth of neutral axis.
Yes, sir.
So here it is compression, and here it will be tension. And at this neutral axis, you will have no compression, no tension. Clear?
Clear, sir.
Now, if in this case, if I say this is my column and it is subjected to compressive strain all over its cross section, and then I draw the cross section something like this. So this is my strain diagram. Okay.
Okay, sir.
Then where is the neutral axis? Yes. आया समझ में? Hello, infinity. See, because see, if I say that if my strain diagram is like this, then this will be the neutral axis position. And if I say that it is like this, then this will be neutral axis position. But if I try to go ahead, it is not at all meeting. रेल के पटरी जैसा है, ये कभी एक दूसरे को मिलते ही नहीं. So the neutral axis position, I will say that at infinity. So I will call this as XU. Depth of neutral axis will be infinity. ये clear हुआ कि नहीं?
Yes, sir.
See, अगर ये clear नहीं हुआ ना, तो you will not understand the design formulas in books. So the neutral axis is away from the column and it is outside the cross section. Okay,
Yes, sir.
that means eccentricity is how much? Eccentricity is 0. And you can say that M, which is mu equal to pu into E, which is equal to 0. And that's why I said that there is only pu. That means I will say that mu is equal to 0. ये कंडीशन क्लियर हुआ क्या?
Clear, sir.
Yes, sir.
That means in books you will see that when the entire concrete cross section of the column is subjected to axial strain, then there will be no mu, only pu will present, and in that case the failure of the column will be governed by crushing of concrete and a strain that is equal to 0.002. Clear? Epsilon C in the concrete. So if this condition is reached, then in that case code says that this cross section is considered as failed. Clear हो रहा है?
Yes, sir.
Now what will happen when mu will go on increasing? E will go on increasing, right? Or when E goes on increasing, mu will go on increasing. वो केस देखते हैं. Again, let us say this is your column and you are having your centroid axis of bending. Okay, so in our case we say 3 3 in ETAP. Otherwise it will be considered as X and this will be considered as minor axis. Now when there is, see, I will say that this P, the position of PU, instead of it is over here, it is somewhere here. At a distance of E. Right? Eccentricity. And I want to draw the strain diagram. You can see this will have a more and this will have a less opposite side. ये ऐसे bend होगा ना? Yes.
Sir.
See this mu, which is nothing but pu multiplied by e. Right?
Yes, sir.
So because of that, you will see that this is a edge on the highly compressed side, and this is the edge opposite to that. It will be least compressed. So I will have a strain diagram like this, and this will be again, this is compression and this is also compression. And then if I try to find out the neutral axis, where is the neutral axis? Somewhere here. So the depth of neutral axis will be this. Yes.
Yes, sir.
So this will be maximum strain and this will be minimum strain, and both will be in compression. Clear? ये क्लियर हो रहा है क्या?
Clear, sir.
एक का ही क्लियर हुआ, बाकी लोग कुछ बोलते ही नहीं है. Yes.
Clear, sir.
Okay. So now this is the case, and you have to imagine what is happening in that case. But now let us say that I see initially your strain diagram was like this, right? Then this went on increasing and this went on decreasing, and finally you got it something like this. Barabar, as E is greater than 0, right? It started moving in one side, so it is more than 0. So here E is equal to 0. As it is goes on increasing, you see that this is going on increasing and this is going on decreasing. So this is your strain on opposite end, and this is your strain on highly compressed end. Yes or no?
Yes, sir.
Yes, sir.
Now कभी तो ऐसा पोजीशन होगा कि for some mu, I don't know the value, but for some mu, you will see that the portion will be like this. यहाँ पे 0 होगा. A strain, I will say that strain over here will be 0, or let's say epsilon. Epsilon will be 0, and here epsilon will be maximum. Yes.
Yes, sir.
Yes, sir. हो सकता है.
So in that case, you will see that depth of neutral axis will be equal to D. Yes.
Yes, sir.
So the first case was xu equal to infinity. Then you can say that there is some case where you will see that xu equal to D. So I will say that this is greater than D, because I don't know infinity. I don't know. I know that it is more than depth of the column. So xu is more than D. Then for some case it will be equal to D. Now as mu goes on further increasing, what will happen? You will see that it will be something like this, and this will be your xu. So this will be compression, let's say epsilon compression, and this will be epsilon tension. And you know what, concrete is not carrying tension, so ये इतना ही हो गया. तो ये बीम का हो गया ना.
Yes, sir.
Yes,
Yes,
This is
sir.
the condition of beam, right? Yes. क्लियर हो रहा है कि नहीं? और नहीं हो रहा है तो पूछो क्या नहीं हो रहा. हेलो.
Sir, it means we design column only for compression.
अरे मैं जितना जितना बता रहा हूँ उस पर कॉन्सेंट्रेट करो. वो आगे क्या होता है, आप लोग फ्यूचर की, आपके दिमाग में फ्यूचर चलता रहता है. डोंट वरी अबाउट दैट फ्यूचर. वो जाएंगे हम वहां. अभी जो
Yes, sir.
बोल रहा हूँ वो समझा कि नहीं, इतना ही देखो.
Yes, sir.
राइट. आगे क्या करना है तो वो आगे जाके देखेंगे. डोंट डोंट थिंक ऑफ दैट. नहीं तो क्या होगा, योर माइंड विल बी डाइवर्टेड एंड the concept that I am going to let you know, you will miss it. मुझे कोई प्रॉब्लम नहीं. क्लियर हो रहा है ना?
Yes, sir.
Right? Okay. Now let us see that what code says that. Code says that when the entire section is under compression, with equal with xu nearly infinity. That means you are having a condition of your strain diagram is this. So in that case, the failure will be considered at epsilon equal to 0.002. So ये पहला कंडीशन कोड ने आपको डिफाइन करके दिया. when this will be the condition. Okay. Now second condition code says that when you are having a strain diagram, and I'm not talking about stress, I'm talking about strain diagram. Not this. When xu equal to d, you will have a strain diagram, and here the failure under such condition, when opposite end you are having no strain and highly compressed edge or highly compressed end will be subjected to epsilon cu, which is equal to 0.0035. So this is your one condition only for compression, and this is your another condition where a strain at opposite end is 0 and highly compressed. So it will be considered as epsilon cu max. You can call it as epsilon cu max, and that is defined by our code, which is equal to 0.0035. Clear? Hello.
yes, sir.
Sir.
Now you cannot have a concrete to go more than this epsilon strain. A strain or maximum strain in the concrete under compression will be equal to 0.0035. And when you are having total both edges, both sides of the column with same compressive strain, then maximum will be 0.002. Now we are not having this condition. and we are not having this condition also. We are in between this, and let us see that. And that is the entire key for design of columns. Let's see that. Now, let's say this is your column. And I will draw the strain diagram. Again, I am saying I am drawing strain diagram. So my strain diagram in one case is something like this. Okay. A strain diagram in other case is something like this. Clear? Yes or no?
Yes, sir.
So what is the value? 0.0035. That is max. Clear? And what is this value?
0.002.
So these are the two extreme conditions that code has defined, and we are in between this. We are never at condition number 1 or condition number 2, whatever you call. You call this as 1, this as 2, I don't mind. मैं ये reference याद रखता हूँ. So under one condition, the real maximum allowable strain that a concrete can carry is equal to 0.002, and in another condition it is equal to 0.0035, and I am having something different case. So practically I am somewhere here and somewhere here, and then code says that your strain diagram should be this. Clear? So this will be E minimum. Okay, this is E maximum. Now, can you find any relation between this? Anybody? चलो मैं समय ज्यादा नहीं लूंगा. What is the value over here?
0.002.
0.02.
What is the value up to this? ये दोनों का डिफरेंस होगा ना, ये
Yes, sir.
दोनों का
Yes, sir.
डिफरेंस. Okay. Hello.
Yes, sir.
And can I see any relation in this? Similar triangle.
Yes, sir.
And what is this?
D, sir.
And how much this?
D/2.
नहीं डिवाइड टू नहीं है, जरा ज्योमेट्री चेक कर लो कैसे
3/7
आएगा.
D. 3/7 D.
यस,
3/7 D हो जाएगा सर.
3D/7.
Yes, sir. वही.
चेक करो. ये सिमिलर ट्रायंगल का चेक करो, and you will see that now based on all this, आप वो एक्सरसाइज कर लो, मैंने आपको हिंट दिया. Based on all these things, code says that E minimum and E maximum are not independent, they are interrelated to each other, and E minimum will be equal to 0.0035.
minus 0.75 least compressed fiber.
Yes. Hello. E minimum is equal to
Yes,
0,
sir,
0. Yes. Multiplied by E max or epsilon max. That is what this epsilon max, 75% of epsilon max will be your this this distance. And that is what I said, you can check it. Not this actually be this. See E minimum and E maximum. So now here you can see that this is your E maximum and this is your E minimum. Clear?
Clear, sir.
So E minimum and E maximum at that condition is governed by this equation, and this equation is nothing but entire thing that I have explained over here. Now you can go and check the mathematics. I'm एक बार वो कंसेप्ट क्लियर हुआ ना तो आई डोंट गो इनटू दिस, वो तो किसी को भी आएगा, एक बार आपको ये कंसेप्ट समझाइए. दिस कंसेप्ट इज वेरी इंपॉर्टेंट एंड इट इज बेस्ड ऑन बिहेवियर ऑफ दैट सेक्शन, and then based on this you will see that entire column design is created. Now we will just go through this because this was the basic thing that see, I have seen people do not read the books. वो बस वो कुछ तो फॉर्मूला मकअप करते और चले जाते हैं. Oh, that's why now the same thing you can see over here how it is being considered. So I hope you people might have enjoyed it. Yes. Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
नहीं, तुम्हारे आवाज में वो दम नहीं है वो.
Yes, sir.
Yeah. Okay, let us go through this, and in next session I will actually go in RCDC because actually that is what I was discussing with Anil sir also कि basic और वो साथ में करना जरूरी है, नहीं तो correlate नहीं होता है. But definitely Anil sir is also going to go through all these basics, but I have best whatever I thought I had gone through that, but I cannot go in much details. But I think once you understand the basics, other things you can get it in the books, and even if you have some queries, I'm always there. But just pura session, matlab pura each and every page I cannot cover in our sessions. I hope you will understand it. Yes.
Yes, sir.
Yes, sir.
Okay, now you can see what is how we are defining. Now, once you understand basics, then uniaxial bending, biaxial bending, and only axial bending, axial compression, all that is very simple, and you can go through that. See, grade of concrete, we are using M20. steel Fe500, clear cover to longitudinal reinforcement as 40. Again, it is as per 456, and floor to floor height is given as a data as 3 meter. Then axial load, that is the data again, is something around 2000. Then moment about x-axis, and that I will say that you consider it as moment 33. So it is 65 kilonewton meter, and moment about y-axis is 25, and the size that we are assuming initially as 300 by 600, and we want to check, or we want to design reinforcement which can sustain these two moments as well as this axial this axial force pu, right? So that is how it is carried out. Now you can go into this. Again, you can see height of column, then unsupported length will be uh, calculated by deducting the depth of beam above. So 2400 is the effective or unsupported length, and effective length, again, this is as per our restraints 0.65. You can see, refer table number 28 of IS 456 2000. So you will get this idea. So 65 multiplied by 2400, which is coming out to be effective length of the column. Okay. Then LEX and LEY, again, you can find out, which is equal to 2040. So effective length 0.85 is recommended since full fixity cannot be achieved. So actually you are getting this, and then you are getting 85. So you can say that 2040 is your effective length both in x and y directions. That means about 2 and 3 axis. And these are the support criteria that I had discussed already. You can see this is for hinge, this is for again some sort of, you can get it through this. So based on that, you are getting the effective length L by R criteria. And now you can see minimum eccentricity. Again, this clause number 25.4 IS 456, which is saying L by 500, D by 30 or 20. Now, people do not understand when you are using D and when you are using B. Yes,
Yes, sir.
बताना पड़ेगा. See, now if I am finding out moment or bending about this axis, then I will have to consider D. Right? Clear?
Yes, sir.
And when I'm considering say bending about minor axis, that is Y, normally Y, and in our ETAB we will be saying 2. In that case, it will be considered as B. क्या करना है, जिस एक्सिस के बेंडिंग अबाउट एनी एक्सिस, उसका जो परपेंडिकुलर, वो एक्सिस को परपेंडिकुलर डायमेंशन जो है वो यहाँ पे ले लेना. बट अगर ऐसा फिगर निकाल के देखोगे ना, तो यू विल बी नेवर इन प्रॉब्लम. बोलना याद रखने की जरूरत नहीं. मैंने कभी याद नहीं रखा, मगर मैंने कभी भूला भी नहीं. ओके, L by 500 plus D or B by 30. So for x axis it is D, and for y axis it will be B. So Ex minimum that you are finding out, and again you can see this clause, lateral dimension by 30 subject to minimum of 20. Okay, so based on that, once you get E equal to 26, because it is greater than 20, this calculation, that's why this is not considered, higher is considered. Then you can find out Mu, which is nothing but Pu into E. whatever E that you have calculated, right? So you are getting this. Again, see this term, which is for change of your units, because this E is in mm, so it is converted in meter. That's why 2000 kilonewton into this. So MUX is kilonewton into meter. So you can see that this dimension has to be in meters. So 52 kilonewton meter. So this is clear. Yes.
Yes, sir.
Yes, sir.
Similarly, minimum.
Y-axis.
Now this is not actually this has to be 300. हमारे हमारे ऑफिस से yeah, yeah, it is about X. It has to be about Y. Yes, yes, it is 300. So I was looking the wrong this thing. Okay, L by 500 plus B by 30, which is 300 by 30. Again, now you can see the 20 is considered. Based on that, you are calculating MUY, which is equal to 40. And then here, moment resisting capacity, that is to be found out. And this can be found out with the help of these tables. Okay, how many of you know these tables, which are, I think it is in
The-
SP.
These are interaction curve.
Yeah, interaction curve. You can go through this and you can find out the with this, but I will explain you interaction curves, how they are prepared. And you can see along x-axis PT by FCK is found out, then PU by FCK BD is found out, and with this for various D dash by D, you will get this and that interaction curve that is used over here.
Yes, sir.
Okay, so but nowadays as people are having softwares with them, nobody is interested in this SP16. तो अभी अभी लोगों को ये देखने का मन भी नहीं करता, समझता भी नहीं. But I will give you a separate session if you like, how the interaction curves are prepared and what is the importance of that, so that we can go through, but not now, but anytime afterwards. So with the help of this, you can find out this. So based on that, by interpolation for mu upon FCK BD square and pu upon FCK BD square, what you are going to find out is you can see for this. So this graph, this graph will give you that P by FCK, percentage of steel required. You can see these curves are used for finding out the percentage of reinforcement. And once you get the percentage of reinforcement, you just have to multiply it and find it. See, you can get it for MUY, and after that, you can see. Okay, this is also one more this thing. I think I will have to go through that interaction curves, etc. No problem. We'll after RCDC, we'll get into that, because this is very this is a complicated formula. Yes or no? Hello?
Yes, sir.
It's not. मैं आपको बताऊंगा, फिर आपको लगेगा यार ये तो फालतू में हम लोग डर रहे थे इसको, ये तो बहुत सिंपल है. मैं आपको
लॉन्ग
बताऊंगा.
कॉलम में ये और भी कॉम्प्लिकेटेड हो जाता है सर.
यस,
लॉन्ग कॉलम में और भी कॉम्प्लिकेटेड हो जाएगा सर फॉर्मूला. MX और MAY भी अलग से निकाल के फिर कैलकुलेट करना पड़ता है सर, सिलेंड लॉन्ग कॉलम।
यस यस, नहीं उसके लिए कुछ अप्रोक्सीमेट मेथड्स है. See, basically, as a structure engineer, one thing you get in your mind that you are not at all going for any exact calculation. You are going on higher side. That's all. See, save हो गए ना, क्या प्रॉब्लम है?
यस सर,
Exact 67.55 निकालने की कोई जरूरत नहीं. You can say 70. It doesn't make, yeah. So practically, see, that is I don't know why the at colleges this aspect is not taught, because we are not interested in exact things. We are interested on safe things. कुछ problem नहीं. 1% 2% higher cost में provide करूंगा, provided you are giving me the guarantee, or guarantee in the sense safety. So the probability of safety is increased to 99%. क्योंकि 100% तो कुछ नहीं होता है. Okay, you can see this based on, this is a formula, and why this formula is coming in picture, that I will explain you. But let's say this is MUX, which is actual bending moment that you have calculated, and MUX1 is the assumed, or it is a you can see you have found it through interaction diagrams based on your assumed AST. Assuming that there is no moment on the another axis. Similarly, this is MUY, which is the capacity, and MUY1 is, you can check it, maximum uniaxial moment. Uniaxial means on another axis there is no moment. So what will be the maximum? So this is actual, and this is the capacity of uniaxial moment. Then this is actual and capacity of uniaxial moment about y-axis. Clear?
Yes, sir.
And this has to be less than 0, less than 1, provided this alpha n is to be calculated, and alpha n is calculated with the help of this PU by PUZ. Now this PU means actual load by your results, and PUZ means it is the capacity of the column with zero eccentricity. That's why it is UZ, zero eccentricity, and it is calculated with this 0.45 FCK AC plus 0.75 FY ASC. So this is the, ideally, if the column is not subjected for any eccentricity, this will be the capacity of the column. That's why it is called PUZ, with zero eccentricity, and this is the actual load. 1 minute. 10 मिनिटांनी फोन करतो, 10 मिनिटांनी. Clear? So you can see this alpha n is calculated something for 0.673 by interpolation. It will be calculated. So PU by PUZ for 2 is 1, and for this 0.8 it is 2, and actually you are getting in between that. So based on that, you can find out 1.788. So this is just what interpolation way, and based on that you can check, and if that check is less than 1, then you are safe, and that is exactly, you can see this has been considered safe. So this is all about and then you can get ASC calculated once you get that percentage, or rho by ASC. Actual, if you go for say all the formulas, then those formulas are very actually this let me give you, see, where from you are getting such type of curves is based on the entire analysis of whatever I have given you, like that for XU equal to this, for XU equal to this. So based on that, these curves are presented, and we are using the curves because that is very simple to use. Otherwise, the calculation, see, you have to calculate the moment for this bar, for this bar, for this bar, for this bar. So all those moments, then add those moments. So that is very cumbersome, and that's why for ready-made charts are prepared. But now the charts are not used because you can provide algo in your without going into this software will give you this value. So this value. Software will calculate this, software will calculate this, and it will come to this, and he will give you this value. So whatever you are doing manually is carried in software. So it is all about axial load and moment on the column, and based on that you can find out the design for columns subjected to axial load, moment about one axis, moment about another axis, or moment about both axes simultaneously. So for simultaneously, it is initially you might find it a little bit difficult, but actually it is not that difficult. So this formula. So if you want to explain me this formula, at least 15 to 20 minutes will need to explain all those things. But right now, I'm not having that much time. So we'll start with continuation day after tomorrow, and then we'll use all these things. Now you must have understood how complicated. If you are supposed to design a column manually, how it is cumbersome. I'm not saying difficult. Difficult नहीं है, मगर you will get tired ये सारी चीजें करते करते. Yes.
Yes, sir.
Yes, sir.
So to avoid the tiredness, we are using software. But this again, this information is very important, and you must understand all these things. I think I have gone through good detailing. I'm not saying best because self design of column is a topic that I need 15 to 20 sessions. Then I can go through each and every aspect of parameters that are used for design of columns. But I think you can get it in the books because you people have done graduation, master graduation, so that should not be a problem. The only thing is that if you go through the conceptual understanding, then it will be more and more clear. So you people will come with difficulties or no? Yes. Hello.
Yes, sir.
कितने डिफिकल्टी लेके आओगे? सर वो पूरा बुक पढ़ा दो, कुछ भी नहीं समझा, ऐसा डिफिकल्टी मत लाओ. Just go through. I think we have given you a few books that we like. One of the best book I have found is by Dr. S.R. Curve, Design of Reinforced Concrete Structures. And one more book is there that is by Menon and Pillai. So Dr. Devdas Menon is currently, I think, head of the IIT department. So Madras, IIT Madras. So that book is also very nice. Have you downloaded those books? Hello.
Yes, sir.
Yes, sir.
Yeah, both books are good. उसमें से जो भी आपको अच्छा लगता है उसके साथ जाइए. But I think these biaxial moments, columns, design of columns for biaxial moment has been more precisely given in Dr. S.R. Curve, a book by Dr. S.R. Curve. तो यू कैन गो थ्रू दैट। और फिर भी अगर नहीं समझा, particularly this, that E minimum and a relation between E minimum and E maximum for bending in the for column section. So if you go through that, then the things are very good for everyone. Yes, any other query? Otherwise, I will conclude. Yes,
एक्सक्यूज मी
सर
सर,
अब हम
अरे
हाँ
तुम
सर,
दोनों पूछते हो, दोनों साथ में पूछते हो।
नहीं समीर समीर बोलो आप।
ओके,
सर ये पूछा था सर, जैसे कॉलम्स ई टैब्स में डिजाइन होते हैं और सर इसमें आरसीडीसी में भी, तो सर फिर हम किसको चूज करेंगे, वो चीज जाननी थी।
सॉफ्टवेयर आप कुछ भी यूज करो, कंसेप्ट वही है। तो रिजल्ट्स थोड़ा आगे पीछे हो सकते हैं, बहुत ज्यादा नहीं। तो आइदर यू कैन गो थ्रू, इसमें आपको जो अच्छा लगे वो कर लो। दोनों दोनों बेहतर है, क्योंकि सी प्रिंसिपल तो नहीं बदलेंगे ना। डिजाइन ऑफ कॉलम, a procedure for design of column is same whether you are using American code, whether you are using Chinese code, whether you are using Pakistani code, if they have, I don't know. तो डिजाइन तो एक ही रहेगा ना, थोड़ा पैरामीटर में थोड़ा इधर उधर हो जाएगा। So if you are using so the same way, if you are using ETAB, or if you are using RCDC, or if you are using Excel sheets, or you may be doing practically, if you understand this SP16, that is also. See, in early days we used to go with that SP16, and hardly we take 10 to 15 minutes for design of entire column. तो ऐसा नहीं है कि बहुत डिफिकल्ट है, मगर वो क्या होता है ना, वो जैसे और एडवांस मिला ना तो पिछले वाला पुराना लगता है। हमें वो SP16 के ग्राफ्स बहुत अच्छे लगता है, अरे कितना समय बच गया। क्योंकि अगर मैन्युअली आपको डिजाइन करने को बताया ना तो इट्स वेरी वेरी टफ, मीन्स कंबरसम, और फिर थक जाता है आदमी। और इतना करने के बाद अगर रिवीजन करनी पड़ी ना तो बात ही खत्म। वो बोलेगा सर नौकरी छोड़ देता हूँ, दोबारा मत बोलना।
यस सर,
बिना पगार दिए मैं निकल जाने को तैयार हूँ। तो वहां पे आपको सॉफ्टवेयर हेल्प करते हैं, क्योंकि यू कैन आस्क हिम एन नंबर ऑफ ट्रायल्स, वो थकता नहीं।
यस सर,
ठीक है। So देख लो, सी you will use ETAB, you will use RCDC, you will use Excel sheets,
आपके लिए
and
सर कौन सा बेटर है सर?
अरे सारी
आपके
चीजें सही है यार,
आप इतने
सारी
दिन
चीजें
से
सही।
इसमें सर ऑप्टिमाइज करके देखना पड़ता होगा कि कौन सा बेस्ट आ रहा है, फिर चूज करते होंगे सर शायद।
नहीं, मैं आपको कहूंगा, अगर आप बेसिक से गए ना तो यू कैन यूज एनी सॉफ्टवेयर। आपको पता चलेगा इसको लेना है नहीं लेना है।
ओके सर।
या सो डोंट सी, एक्चुअली अगर मेरी बात पूछते हो तो आई डो नॉट यूज RCDC as well as I do not use ETAB for design of columns। मैं क्या करता हूँ, ETAB में उसे डिजाइन करने को लगाता हूँ, एंड आई फाइंड the worst case for that, and for that worst case I apply it in my Excel sheets and I get the results। वो जो 64 या 34 35 जो केसेस दिए ना आपने अर्थक्वेक के लिए, विंड के लिए, सो फिर रिस्पांस स्पेक्ट्रा है, तो वो करीबन 50 केसेस हो जाते हैं कॉम्बिनेशन के।
यस सर।
तो उसमें से ये ETAB को मैं ऐसा करता हूँ, आई गो फॉर ETAB एनालिसिस एंड डिजाइन, और डिजाइन करके वो कॉलम का उसने कौन सा वर्स्ट केस फाइंड आउट किया है, तो मुझे वो 50 कैलकुलेशन करने की जरूरत नहीं पड़ती। मुझे लगता है यस ये वर्स्ट केस है, अब ये वर्स्ट केस का मैनुअल और हो जाता है वो। बट आई डोंट ब्लेम आरसीडीसी। आरसीडीसी भी बहुत अच्छा है, मैं यूज नहीं करता हूँ। इवन ई टैब तो आई जस्ट कांट से कि ई टैब की वजह से ही ये सारी चीजें हाथ में आई मेरे। मगर ई टैब अच्छा है, बट आई डोंट यूज फॉर डिजाइन, आई यूज ओनली फॉर एनालिसिस एंड गेटिंग द वर्स्ट कॉम्बिनेशंस। ठीक है,
ठीक
यस
है
सर।
और थोड़ा प्रैक्टिस करोगे ना आप, तो आप लोगों को भी ध्यान में आएगा कि क्या करना पड़ेगा। एक प्रोजेक्ट, दो प्रोजेक्ट, तीन प्रोजेक्ट हो गए ना, चौथे प्रोजेक्ट में आप किसी को पूछेंगे नहीं, बोलेंगे तुम्हारा ज्ञान तुम्हारे पास रखो, मुझे पता है मैंने क्या करना चाहिए।
सर, आपने ड्राइंग नहीं भेजा।
अरे भूल गया, कल कल भेजता हूँ।
सर ये आप मेल आईडी चेक करना एक बार आप।
नहीं है, वो मिला है मुझे, तुम्हारा
मेल।
मेल आईडी मिला है,
अच्छा,
वो व्हाट्सएप पर है।
आप सर देखते नहीं है, मुझे याद दिलाना पड़ेगा कॉल
और
करके आपको।
नहीं, वो व्हाट्सएप मैं यूज नहीं करता हूँ ज्यादा यार, क्या
मेल
करूँ।
आईडी मैंने वहाँ व्हाट्सएप पे भेजा था।
हाँ व्हाट्सएप पे है, एक मिनट, अभी अभी बोलता हूँ। कहाँ पर है?
मैसेज करता हूँ मैं।
नहीं, है यहाँ पे, बताता हूँ। सर टुमारो मॉर्निंग वी कैन मीट, कैन यू प्लीज पुणे सेंटर 4 तुम्हारा नंबर क्या है?
मैसेज किया सर मैंने।
अभी
हाय लिखकर।
मैसेज किया,
या।
हाँ, या 39911।
यस सर।
अविनाश कुमार सिंह,
यस सर।
या aviraj.3456@gmail.com।
यस सर।
हाँ है, मेरे पास है वो मैसेज। ठीक है, भेज देता हूँ, कल कल भेज देता हूँ। और जो अभी रिसेंटली मैं जो प्रोजेक्ट पर काम कर रहा हूँ ना, उसका ही आर्किटेक्चरल ड्राइंग और जो फ्रेमिंग मैंने फाइनल किया है
यस
वो
सर।
भेज देता हूँ। यू कैन स्टार्ट, और ग्रुप में सबको दे देना।
यस सर। यस सर।
राइट फ्रॉम सुलेखा मैडम टू एवरीबडी, जितने भी तुम्हारे ग्रुप में अटैच है ना अपने, ये
यस सर।
सबको भेज देना।
ओके सर।
जिसको करना है वो करेगा। अब मैं किसी को कह तो नहीं सकता हूँ ना, करना ही पड़ेगा। आ, वो उसका फायदा ये होगा कि राइट नाउ आई एम वर्किंग ऑन दैट, एंड विद इन 2 to 3 days आई विल बी इशूइंग द एंटायर ड्राइंग। तो अगर आप लोगों ने ई टाइप का मॉडल बनाया, तो आपका और मेरा रिजल्ट्स में हम लोग चेक कर सकते हैं क्या क्या फर्क है।
यस सर।
या ओके देन, thank you. So we'll conclude today's session, and day after tomorrow we'll directly go to RCDC, and we'll see how immediately it can give us all the design of all columns at every floor level.
ओके सर।
Okay.
Okay, sir. Thank
गुड
you.
नाइट
ओके
सर।
सर।
Thank
Okay,
थैंक
sir.
यू सर।
Good night, sir.
Good night. Good night.
Thank you, sir. Good night, sir.